A very warm welcome to today's lecture on relational data modeling. In this lecture, we'll be taking an overview of what it's like to structure a data model, or what are exactly data models, and then we'll see how to structure these kind of data models, which we'll encounter in different sectors at different stages, and also a standard top-down approach to produce a database that is conceptual, relational, schema, and relational database. So from conceptual model into a transformation to relational schema and to a relational database. So today we'll be looking over how can we develop a conceptual data model, and also how to produce a relational data model from a conceptual data model. So from a concept, how can you create a relational data model that has some things that you have in your mind as of now, but you have to get it down to a piece of paper or into a database in the digital world. So, but to better understand what data modeling is all about, let's take an example. So for a moment, let's forget about data modeling. Let's forget about relational databases. Let's forget about relational schema. Let's understand, why is data modeling important? So let's just consider that you have been appointed as a data analyst at the Maruti Suzuki showroom as a job opportunity, and there, once you have joined this job, your first task is to analyze that which of the salesmen has sold the highest number of cars or the highest number of vehicles. So you have to find out as the first task that who has sold the highest number of cars, and you have this physical register wherein each sales is every sales. Let's say it's not the 22nd century in 2022. Let's say it's still year 2000, and data is not yet sitting on a relational database. It's still in the old data keeping techniques, that is on a register or a notebook or something, some physical place. So your first task would be, as a data analyst, as a relational data analyst having some knowledge of SQL or SQL, structured query language, to get this data onto a database. And how will you get this data on a database? Would you just copy the register and create a single table to do your analysis, or how would you like to take into this problem? Just think for a moment. Think about this for a moment, that you have a task, you have these, think of this as a business problem, that you have this register with different sales people making different sales of different car vehicles, and every car sold will have an invoice, and these are some key hints of which you can use. So I hope that you have taken into account a bit of thinking into this problem, and now let's see how can we handle this kind of problem situation or a problem statement. How can we go forward of creating a database from this problem? So yeah, there it is. So every car will be assigned to a mechanic once the sale has been done, or once a car enters into the showroom. The mechanic will do some security checks, will make sure testing of the vehicle, everything, the brakes, the oils, engine oil, and the engine engine maintenance, and also these parameters are on mark, that the features that we have been offering, that we are offering to our customers, are perfectly okay. The car is perfectly fine to start running on the road. Like that, we have to think of this as a business problem, that you need your data first of all to be in place. Only then can you manage this business process, correct? So say it's not just one showroom. Maruti has, say, 100 different showrooms across Delhi. I'm just taking into account an example. Say Maruti has 100 different showrooms. How do they keep in account of every car, vehicle? How can they? It's not possible to be online with mechanic all the time, that okay man, have you seen the vehicle, it's all right, it's perfectly fine to go. And sometimes, with having 100 different showrooms across the state, it's human memory is also subject to forgetting, have this problem of also forgetting sometime, and you might be required to call the mechanic again and again to make sure the same thing is perfectly fine, or when was the servicing done, in case some customer has some issue or something like that. Making sure that your business process runs smoothly, even at a scale of 100 showrooms where there are several different salespersons and thousands of cars, making sure none of them were stolen by anyone or anything like that happens, to keep in account of everything is running smoothly fine and everything is taken care into account. So we have to manage this business process into this kind of a database problem, and also we have to make sure that that particular person, that mechanic, gets in data of all the cars that are there inside the showroom, that the salesperson has the data of what are the cars available to be sold, the mechanic has data for the maintenance of cars, what all cars need to be maintained. So there have to be at least 5 to 6 tables that needs to be created in this kind of a business problem, wherein the invoice number will have a sales ID, and each sales ID will be connected to a customer ID, and each customer ID will be connected to a car ID. So this is how our data mapping should be done, or data modeling of this data should be done, in order to ensure that we have a smooth table, that there is something connected to some point, and it's not just tables created in black hole that have no significance to each other. We also need to make sure that they have a significance to this business problem, that that there is a need for a mechanic to be assigned to an ID, and there's a need for a date on which he opened the ticket for a car ID. So this is how the interconnection should be done between the tables. Also, like here in this, the customer table should also be attached to the car table with the car ID. Like once the sales has been made, to the invoice ID you should also be having the car ID, right? But this is just for an example. But considering this business process, we can see that that each invoice number will be connected to a customer ID, and each customer ID will be each customer. If the sale has been made or in a car showroom, it must be of some car or some car accessory only. So it must be with some car ID, and that car ID, in case it's an accessory, it should be an accessory ID. So this kind of an organization will make it really easier, man, if you can think now that considering the previous business problem that seemed almost impossible to be solved, now we can think of this into a relational database problem, and using these data modeling techniques we can understand that this can now be organized in a pretty good way, that this seems very neat, and this won't create too much confusion between the colleagues themselves and your business process. So let's understand a bit more about the kind of modeling techniques that are there, and how can we leverage that under different business problems. This is gonna be really interesting to know. So there are different kinds of problems that we deal with. There is, say, different kinds of modeling techniques. The first one is the conceptual model. There's conceptual data modeling, there's logical data modeling, there's relational data modeling. So let's understand of what conceptual modeling really is. So it deals with entities and attributes. So when I talk about entities, I mean these entities. So salesperson, that salesperson is an entity that is connected to an invoice number. Each salesperson, like say our business problem was to identify which salesperson has sold the highest number of cars to any customer. So here each salesperson will have a relationship, that is an entity relationship to an invoice number, and that invoice number will be connected to a customer number. So this is how the salesperson ID will be connected to the customer ID. Or here also we can directly create this kind of relationship. This is a logical modeling concept, logical data modeling. So there is this kind of relationship which we can see over here. But in case of relational data modeling, we can see that that we can do something like each salesperson ID will have a column. The salesperson table will have a column called customer ID, which will be the sale, which will be the customer to which the salesperson sold that car. And using this kind of data, then we can understand of which salesperson made the highest number of sales during this financial month or during this financial year. So these entities and their attributes is the main concept in this conceptual modeling, data modeling concepts. It deals in entities and their attributes, how these entities can be connected to these attributes. By attributes, I mean these different parameters of the tables. These are entities, salesperson and invoice, while their attributes are the different columns we have in these tables. So it deals in entities and their attributes and the kind of relationship that these entities have to these attributes. So here there is a one-to-one relationship between each salesperson will be connected to an invoice number, or each salesperson will create an invoice number. And there is a one-to-many relationship as well, that every salesperson can make multiple invoice numbers also. But in case of a single column, it will be just one invoice number, and each customer ID will have an invoice ID. It will have some invoice number which will be generated on the sale. And similarly, while rarely a single customer can also buy multiple cars too. Well, although that happens very rarely, but in case it's a family, there's a customer who wants to buy a car for his mom and dad as well. So very rarely, but yeah, it could be possible that one customer can buy multiple cars. Maybe during one financial year he bought one car, then during the next financial year he could be buying another car. So while we are still dealing with conceptual modeling concepts, it's also important to understand how this data can be visualized on a non-relational scale as well. As these days there are also a lot of NoSQL databases NoSQL data modeling that is really popular due to its underlying advantages of the ability to analyze and visualize unstructured and semi-structured data as well. So this conceptual modeling associates these entities that have some data associated with them, and it creates hierarchies among this modeling concepts. And this modeling happens without considering the target database. So here the problem is not the target database, but the problem is about structuring your data into a business problem that solves it, and that is scalable and also a bit flexible also. So whenever we are dealing with data modeling, it's important that we create a data model that is scalable as well as flexible as with the needs of business. Say today we are selling cars, tomorrow we could be selling car accessories as well, just to help with generate more revenue and more sales. We could be selling car accessories as well. So it should be flexible in that sense that the architecture can be changed if required in the future. After that, we come to the relational data model. So these basically deals with also attributes, but in terms of relation between these attributes. Like we were just talking about, that this salesperson table can directly have a customer ID in case this was a relational database, in case it was a relational data modeling concept used over here. So we can use multiple concepts, and like this we could be having primary keys and foreign keys. So while conceptual data modeling concepts deal with the entity and their relationship between these entities, the relational data model primarily focuses upon primary keys and foreign keys that, okay, each customer ID. Now this customer ID table will be having the customer name. So each salesperson can have an invoice ID, a customer ID, something like that. So this is a relational data model, and there are also some constraints that, okay, that each customer will always have a car ID, will have a serial number. Each car will have a serial number. This could not be that there is no serial number, that a customer bought a car but there is no engine serial number, there is no serial number on the engine. So this seems a bit more impossible to happen, that each engine will have a serial number, will have its RC registration car number once the car gets registered under the government. And gets an RC registration certificate. So relational data model emphasizes more upon these constraints and data integrity, that data is always organized and is waiting on our cluster, on our Hadoop cluster or relational database to be visualized once it's exported to some Power BI or Tableau or whatever tool your organization might be using for visualization of this data. Now, the assumption in modeling is that, with conceptual modeling, is that it does not consider the target database. But when we are dealing with relational modeling, it assumes that the target database will always be relational, that will be having some sort of relation among itself. Without a relation between the salesperson and the customer ID, it would not be possible to relate these two tables. So this kind of relational data model can only be used when there is a relationship between them, when they are relational among each other. Now let's take a brief look about the differences between we have talked about, but let's take a bit more detail. So we know that these entities become relations in case of relational database model. However, multiple entities may merge into a single relation. Like we were just talking about this example, that this could be merged with the customer ID right over here also. So that means multiple entities can merge into a single relation in a relational database. And more commonly, new relation can be introduced in case of relational database modeling. And these one-to-many or one-to-one or many-to-many relationship can become foreign keys, that car ID. Each customer can be connected to car ID depending upon how many cars he bought. So this seems more scalable. Now we're thinking at more depth over here. Now foreign key is an attribute in a relation that contains the primary key from other columns. So like customer ID will be having a customer name in the customer table. That is a primary key over here, but once the customer ID comes here on the invoice number, it becomes a foreign key over here. Now it's a foreign key. So that's an example of foreign keys, and these may be included in a conceptual model, but these cannot appear in a relational database model. So these needs to be resolved using some kind of relationships. They could be one-to-one, many-to-many, or they could be inheritance of these hierarchies that we have in our table. Like an invoice will have a customer ID, so the highest one would be invoice, and similarly so on and so forth. So we have to form some association of these entities to some attributes or to some relations. That's the key concept over here to understand between these two kinds of data modeling techniques. Now taking a bit more depth about this kind of example problem. Now taking an example of a college database, that each customer, that each student will have an enrollment number or his roll number, via which would be a unique number assigned to every student in their college or their university or their high school, whatever it might be. So this has to be a unique identifier for each record or a row. That is, each relation must have this primary key, and without this primary key it will be impossible to locate that particular column. And then we can, by their name, we can generate their initials, maybe something like that, and also the kind of college. And then there could be that student ID and their college in case it's a university database. So one student will always have one university, or one teacher will have a particular college ID assigned. Then similarly, one person will have, or one car registration number will have one person registered, or one person ID can have multiple car registrations under his name. And many-to-many, like many lecturers can have been teaching many students, can, like same way like a person can own many cars, but a car can only have one owner. So now similarly, many lecturers can have many modules. Then a single module can also have many lecturers. So like many to many both ways. So many lecturers can have multiple modules, while many modules can have many lecturers, while a single module can also have multiple lecturers. Say your English module, like your English literature teacher is different and your grammatical English grammar teacher could be different. And similarly, many cars can have only one owner. So even though if there are many cars, it will always have one owner. And like one team will always have one coach. So that's a one-to-one. Now taking a bit more depth of to recursive relationship, or we also call it as reflexive association. That is, let's take an example of, say, one person ID can be married to many ladies. A single person can be married to many women, while one person ID is married to many women. Same way a single married woman can have multiple husbands as well. So this is kind of a recursive problem, while that there could be that the married lady is having just one husband as well. So this kind of a relationship where multiple things are possible depending upon the subject, depending upon the religion of the person. Like lots of things can come over here to determine what's the status, what's the kind of relationship that we have among the table. Like we just discussed, that there could be one woman also that the person is married to, while there could be multiple women, and similarly this happens in a vice versa way as well. Now coming to the generalization, or we call it specialization, hierarchies. So like we were just discussing in the invoice thing, so same way here in case of the university database, that we can say that the student table is the parent table. Now the course that he's taking is the child table. That the first degree, which will have a professor ID, and same way that there is a teacher table is also located in the database. So these are some examples of different kinds of relationship which we can have in data lifecycle, data project lifecycle. And similarly, there could be a relationship within a schema, that is, a foreign key can link a relation to another table, like each department in a college, computing, electronics, will have a coach ID or a teacher ID, and similarly that teacher ID will be a primary key into the teacher's table. And this is also an example of one-to-one relationship. So this was a brief about what data modeling is all about, and what are the different relationships between these kind of modelings which we can encounter under different cases in different projects. So I hope you guys were able to understand and take some notes during this lecture. I would like to see you in the next one. Till then, happy learning.